All right, we are in Chapter 1, Section 3 for IM1 called Solving Equations. So we're going to review a little bit of the language of algebra here at the top, and then we're going to look at some translating phrases and algebraic expressions, key phrases, at the bottom of this page. Well, it's actually the middle of your page, but I split them up just to make it a little bigger on my drawing application here. So first, we're just reviewing some of these basics. So variable is a letter or symbol used to represent any unknown quantity. So remember, that's all a variable represents. It's just something we don't know yet, so it's a placeholder. Numerical expression is a collection of numbers, operations, and grouping symbols. Algebraic expressions, a mathematical sentence containing variables. Algebraic equation, a mathematical sentence statement that two expressions are equal to each other. So algebraic expression, 2x plus 5. Algebraic equation, 2x plus 5 equals 1. And I'm even going to go a little farther and say equals x plus 1. Why not? Just so that we have kind of two more expressions here. We can just say equals 1 also. That's still perfectly fine. I was just making it a little bigger. Numerical expressions. So these are all examples of some numerical expressions here. And then a variable, the variable expression, or the variable example here would be x. And we don't necessarily know what x equals until we start solving this. So if we scooch down here, we will see what we want to do is focus in on some key words and phrases for these types of operations. And this is for translating algebraic expressions or equations. And since we have equal here, this would also include equations. From a verbal expression into an algebraic either expression or equation. So addition, you can simply see the word add. Sum, and remember this is a big one. This means that it's the answer to a addition problem. So usually we see sum of, and so we'll see the sum of, and then the next two things that it lists, we're adding. More than, increased by. So these are just kind of some of the basics. There's definitely more. I'm just throwing a few of them up here. Subtraction, so subtract, that'd probably be a pretty easy one to identify. Difference of, so there's another one. Difference of means if I say the difference of, and then the next two terms are being subtracted, or the next two items in the sentence. Decreased by, less than, so I'll kind of go in the same order here, less than, decreased by. So these are all things that kind of tell us it's going down, and these are all words that were telling us it was going up. Multiplication, so we can literally hear the word multiply. That's pretty easy. Product of, so this is another one where we hear product of. That means that the next two pieces are being multiplied. Of can also be used here. Times, doubled, twice, triple, there's all kinds of different words that let us know right away I'm multiplying. Division, so you can literally use the word divide. Quotient of, so this is and I keep putting these all in the second one. So the first one I'm listing are kind of the obvious ones, add, subtract, multiply, divide. But then the second one is usually it's followed by of, and it means that it's going to say quotient of, and then the next two pieces we're going to divide. You can also say per or ratio of, fraction. There's quite a few other ways to say these things. And one thing we do want to be careful of are the order. This actually just came up in one of the other classes. So if it says this quantity, and I'm just making it up, pretending like we're reading something here. So x squared minus 5, and it says subtracted from 80. So that's the next part of the sentence. Well, I wouldn't go minus 80, because what it's saying is this whole quantity that I just wrote out here is subtracted from 80. So you really need to be careful about the wording and make sure you're paying attention to that, because if I were to put it in the wrong order there, I'd probably end up with a negative where I should not end up with negative, because I'm subtracting it in the wrong order. So just be very careful about the wording. Make sure you understand or you're listening to what it's saying. Equals, so this one's pretty easy. If I see the word is, which is usually what we're going to see, that means equal. Also, equal is the same as is kind of overkill for is. So there's a few different ones. I've even seen, I think, total of sometimes can tell you that, but usually we're going to see the word is or equal. So as soon as you see that two-letter word, equal sign. All right, let's go ahead and switch to the next page here. So identify key phrases in the expression that what is the mathematical operation? Does the sentence represent an expression or an equation? Most of the time you will write just like it is stated. So like I was saying on the last page where I was saying, and actually they give us beware of turnaround words. So they're warning us on this page. If you are given less than or subtracted from, you want to reverse the order of the algebraic sentence. So they're actually pointing this out to us on this page. So an example could be 6 less than a number. So we have less than, it's saying it's 6, and we're taking that away from this number. So we want to make sure we write n minus 6, not 6 minus n. That would change the expression. So in this case, this is just an expression. There's no equal sign. Okay. What's the mathematical operation? Less than means subtraction. Right. So I'm just going through and answering some of the questions that were up above. All right. If I scooch down a little bit more, identify the key phrases needed to create a verbal sentence. What is the operation or operations? Is the sentence an equation? Excuse me. So we're going to practice. We're going to write each verbal sentence. Write a verbal sentence to represent each equation. So it's automatically telling me these are equations. I can see that pretty quickly. They both have an equal sign. So that second question was already answered. What is the operation? So in this case, I can see I'm subtracting. And in this case, I can see I'm adding. I'm also doing some division here, because that's what a fraction means. It's division. So I've identified some of my operations, or all of them, just kind of across. So now we would have g, or the variable g, depends on kind of how picky the program is that you're typing it in, but g minus 5, or the difference of g and 5, you could write that also. So again, there's more than one way to write these, is 4. And I'm writing the numbers 5 and 4, but really we should be writing 5 and 4, because this is what you're going to be expected to do on Alex. So be careful about that. I was being a little lazy and just writing 5, the number 5 instead of the word 5, but Alex will want you to write it out. All right. So now we have x divided by 4 plus 8 is negative 16. So is this the only way to say this? No. I could say the quotient of x and 4 increased by 8 is the same as negative 16. So I could switch all of these words up pretty much if I wanted to. This is just kind of the simplest way I can think to say it. It's just x divided by 4 plus 8 is negative 16. So keep in mind, more than one way to solve these ones, or not solve them, but write them out. All right, I believe this is still part of the section here. So we're going to go through a couple more properties. So the reflexive property, and we definitely use this one, quite a bit, especially once we start talking about geometry. This one's pretty common. So for any real numbers, a equals a. So it's just saying a number is going to equal itself. So an example, we could say b plus 12 is equal to b plus 12. So it's just a number equals itself. It doesn't matter what the number is. Since it's b plus 12, we're treating it like one number. If I knew what b was, I could add it together. B plus 12 is the same number. All right. Symmetric property for all real numbers, a and b. If a equals b, then b equals a. So this is pretty common. We understand this one. We can flip it around. It doesn't change the equal sign. So it says if 18 equals negative 2n plus 4, then negative 2n plus 4 equals 18. So they just flipped it around. It means the same thing. So I'm not changing anything. I'm just flipping it around. So let me scooch down here so you can actually see this next part. So transitive for all real numbers, a, b, c. If a equals b and b equals c, then a equals c. So I kind of like to call this one the jump property. And I like to do this little step down so you can actually see a equals b, b equals c, like this. So we can actually see that it's matching here, and I'm jumping from a to c. And this can keep going. I've even seen, you'd be able to do something like this, and you could keep going all the way to z if you wanted. As long as you have them lined up, you can cross them out. I can jump from beginning to end. So this looks a lot like substitution to most students, or quite a few students that I've dealt with doing this property. But it is a little different, especially if we're making that bigger jump. So this one we have x, if 6 plus 1 times x equals 21, then 7x equals, oh, I'm sorry, I jumped to the wrong one. I was going to say that's not an example. If 5p plus 3 equals 48, and 48 equals, and I'm even going to line this up better, 48 equals 7p minus 15, then 5p plus 3 equals 7p minus 15. And we can see this, I can even show you, it crosses off, so I'm jumping from beginning to end here. So that's all that's happening. I can kind of see that line up, and I can get rid of that duplicate. And I can say, okay, well then I know these two equal each other, and I can start to solve. So these only have one variable, kind of easy to solve them without doing this step, but you can put them together. All right, we have one more property at the top here. Oh, two more, because it's putting two tables together from the book. Substitution. If a equals b, then a may be replaced by b, and b may be replaced by a. So the example in here that they give us is if 6 plus 1 x equals 21, then 7x equals 21. So what they're saying is, in this case, a is 6 plus 1, and b is 7. Well, I know these are equal to each other. So I can replace a with b, or b with a. So instead of saying 6 plus 1, I can replace it with 7. That's what this example is showing us. For any real numbers, a, b, addition and subtraction. And this is addition or subtraction properties of equality. For any real numbers, a, b, and c, if a equals b, then a plus c equals b, and plus c, and a minus c equals b minus c. So what this is saying is, if I add c to one side, I have to add it to the other. If I subtract it from one side of the equation, I have to subtract it from the other side of the equation. So let's look at the example here. We have x minus 6 equals 14. And I can add 6 to the left side, but I also have to add it to the right side. And I'm even going to kind of highlight this, add 6, so you can kind of see this is the addition that I'm doing. And now if I were to continue this, they would cancel because it's a positive and a negative. It's the same number, and I have x equals 14 plus 6 gives me 20. So I went a little step further that you could see that. I don't think we necessarily need to keep going that far, but I just want to show you that's the point of this property, is so that you can solve. You're removing what's being added or subtracted from the variable. All right, multiplication and division property of equality. For any real numbers a, b, and c, as long as c doesn't equal 0, if a equals b, then a times c equals b times c, and a divided by c equals b divided by c. So this is pretty simple, or similar to the addition property here. If I'm multiplying by c on the left, I have to multiply by c on the right. If I'm dividing by c on the left, I have to divide by c on the right. So it's that idea of keeping things equal. Whatever I do to the right side of the equation, I have to do to the left side of the equation, or vice versa. Whatever I do to the left side, I have to do the right side. So let's look at the example here. We have m divided by 8 equals -7. So with this one, if I want to get rid of a fraction, I'm dividing by 8. What I would want to do is the opposite. I'd want to multiply by 8 on both sides. So now, again, just like I did earlier, I'm going to do this and then kind of take it away because it's going a little farther, but 8 divided by 8 cancels, and I just have m equals -56, because all I've left is m, and then I would multiply my two pieces here. So the reason for doing the opposite is to cancel something out. That's the whole purpose. All right, let's look at the last page here, and we'll be all done with section 3. So solve each equation. So first, what's being done to the variable? I'm subtracting 14 and 29 hundredths. So I'm going to add 14 and 29 hundredths to both sides of the equation. Remember, balance. We have to stay balanced. X is going to come down. Any number minus itself cancels. Remember, this is the inverse property we used in the last section. And then we have 25 plus 14 and 29 hundredths. So it's going to be 29 hundredths. I already know that. 29 hundredths. Sorry, I almost said thousandths. That's hundredths. So now I just have to add the whole numbers here. So I have 9 and 3. So x equals 39 and 29 hundredths. All right, number 2, we have a fraction. So whenever you have a fraction by the variable, remember we're looking at what's being done to the variable. Technically, I'm multiplying by 2 and I'm dividing by 3. I'm doing this two things at once when I have a fraction. So what I want to do, and I'm going to erase this too just to get it out of my way, I want to do the opposite. So if I'm multiplying by 2, I want to divide by 2. If I'm dividing by 3, I want to multiply by 3. That way they cancel out. 3 divided by 3 is 1. 2 divided by 2 is 1. And I'm going to do the same thing on this side with the 3 halves. So I have y equals, now I'm going to multiply across the top. And you can also do some simplification here if you want to first. But we can go -18 times 3. So we end up with 54. And then we can divide by 2. So divided by 2, we get 27. You can also say -18 divided by 2 is 9, and then multiply by 3, which you still get 27. So just remember, you're multiplying, you're dividing. Okay, that's two operations at once. All right, this guy here, so we have to simplify first. So we're going to distribute. So we have 2 times 2x, that's 4x. 2 times -1, it's -2. Now we're going to distribute the -4, not just the 4. This is the -4. So it's -12x when we multiply by 3. -4 times 1, -4, and that equals 2. So now we have some like terms we need to combine. We have 4x, 12x, -12x, and we have 2 and -4. So -2 and -4. So I'm going to combine these guys, and I have -8, because positive 4, -12. I'm going to subtract. 12 is bigger and it's negative. -2 minus 4, or plus -4, if you want to think of it that way, they're both negative. So I'm going to combine them and keep the negative sign. I had -2. I'm going 4 more negative. All right, now we've simplified and we're going to start to solve. Now I can ask the question, what's being added or subtracted to the variable? 6 is being subtracted, so I'm going to add 6. And bring it -8x down. 6, positive and negative cancel. This is a 2, sorry, not a z, that kind of looks like a z. 2 plus 6 gives me 8. Now I'm multiplying by -8, so I'm going to divide. Boop. Anything divided by itself is 1. And so x equals -1, because 8 divided by -8 is -1. This isn't anything divided by itself. Technically, it's a positive and negative. Yes, they're both 8s, but we have to keep that negative in mind. All right, the last piece here, we have solve for the variable. So this is something we want to learn how to rearrange the equation sometimes so that we have what we want all by itself. So this is usually one of the situations where I'm given all the other pieces here, but I'm not given h. So I want it to equal h. I want to kind of rearrange it and manipulate it a little bit here. So first, let's see. What I would do first is subtract 2 pi h from both sides. Or you could subtract this guy for the other side. The main thing is you know what? I'm going to switch up so I don't have to do it twice. I'm going to move this one instead. So then I don't have to move something twice, because now I'm going to have to move s if I moved that one. So I'm going to move this one first so that it's all by itself already. So I'm subtracting from both sides. So now I have s minus 2 pi r squared equals 2 pi h. So now to get h by itself, all I have to do is divide by the pieces that are being multiplied here. And I can do that together. So I'm going to divide by 2 pi on both sides, like this. Remember, this is everything being divided, so I can't just go like this and cancel them out. That doesn't work, because it's s divided by 2 pi and 2 pi squared divided by 2 pi. So we don't want to cancel that, because then we would have to indicate this is a separate fraction. But I can cancel these guys, because this is just one piece. So the end answer would be, and I'll just write it off to the side over here, s minus 2 pi r squared divided by 2 pi equals h. Now, can I move the h to the front so it says h equals? Of course I can. So, and that's actually probably the way it'll be on Alex. It'll say h equals, and you start typing it in from there. But it doesn't necessarily matter if it's on the front or if it's on the back. It means the same thing. All right, I believe that was all of section 3. So we are all done. I will see you in section 4.